Good day. This week's topic is infrastructure systems. This topic is we're taking, for example, the different types of infrastructure sectors, and we want to not just look at them individually, but take a holistic approach, which needs to be used, i.e., consider the impacts of new infrastructure and compatibility with other existing infrastructure sectors, systems, or components. And this we would want to do if we're building new infrastructure or changing any of the existing infrastructure. Therefore, we need to understand the infrastructure systems and the interrelationships between the different types of infrastructure, the systems or the components of some of the sectors. And this is something we'd want to do during the design process. In terms of infrastructure sectors, just remind you of the sectors we learned about at the start of the course. Transportation, of course, which could be land, water, air, or space modes. And then, of course, within land transportation, we can have different type of infrastructure systems. We can have rail, highway, etc. And then, of course, we have water management, where we have water supply, wastewater treatment, stormwater management, energy. We've talked about the electrical and the petroleum systems. And there, for example, we can use a petroleum source to generate electricity. So there's some interrelationship there. In terms of solid waste management, there would be a relationship, for example, between solid waste management and transportation. That is to say, we need to move our solid waste from the city to the municipal landfill up Highway 11 North in North Bay. So there's an interdependency there to manage the solid waste. And then, of course, all of our public facilities also rely, the use of those public facilities relies on the transportation system. And we have to think about, if we're going to build a new, for example, super high school in North Bay that was proposed where the Chippewa site is, we would need to consider the increase in traffic and if we need to make improvements to the transportation infrastructure. Communications, of course, most of that now is done through cell and telephone or internet. And then we have our Earth monitoring system. Now, for example, GPS, Global Positioning Systems, is a way we can track locations on the Earth. But it has applications or becomes part of our transportation sector or supports it in terms of everybody has a GPS on board their car now or in their cell phone, so they can know where they are. So the transportation or the navigation of the vehicle for transportation purposes is relying on the satellites and the GPS system that's been installed, and it all has to work together. So if we, for example, we go to autonomous vehicles, we will be relying very heavily on all these infrastructure components and systems to guide our vehicle. In terms of the different sectors, this is a diagram that sort of shows, okay, this just points out we have an interrelationship between some sectors. These sectors are not the same as I have in the first slide. It's from a textbook we used to previously use. But here we see transportation and hazardous waste. So we need to move hazardous waste to a site where it's going to be managed and dealt with, and it relies on the highway to move it in the truck. Energy sector supports transportation, of course. We need petroleum fuel stations along our highways. So that's sort of where you have interrelationships. And these lines between the different circles can change depending on the system. So, for example, now we can take the transportation sector and break it down into different systems or types of transportation. Here we have rail, highways, ports, mass transit, waterways. Maybe we have a bicycle or pedestrian transportation system. A lot of cities now have bicycle paths, so that's specific to the use for bicycles. In Toronto they have this now, and it's part of the transportation system, or component, shall we say. See, here they have streets highlighted, so the city streets could be a part of our transportation system or a component of our transportation system. We move to the next, and you'll see we break down the street system. So for streets to operate properly, well, we need to now have traffic control, traffic lights. We need to have parking systems. We maybe have street lighting. And then we can even get into the different types of streets, where we have the local versus the collector streets versus the arterial streets. And these are just different classifications of streets. But again, this whole system has to work together so that the traffic can flow efficiently and safely within all our streets. As we said at the start, compatibility of infrastructure systems. That is to say, a new component or subsystem must not be adversely affected by other system components or subsystems, nor must it affect other system components or subsystems. So if we're building something new, for example, we're building a new subdivision in a part of town, the infrastructure design for that must take into account, say on the stormwater management side, that we have to consider the downstream developments or infrastructure that's there. So anything we do in the new development must not increase the stormwater flows downstream, causing flooding, for example. So that means that anytime we make a change or modification, that we don't want to adversely impact another part of the infrastructure system. Hello, this week's
the rest of the slides in this
system presentation are some case studies.
Infrastructure
from almost the textbook we used to use.
Always think about
and
taking a holistic
approach.
That
you can read through these.
They're the impacts of any new infrastructure or changes to that infrastructure.
Systems and how they work together
with other infrastructure systems or components
in places where they work well together,
near
like
to
in America versus in Africa.
So that means we need to understand the systems that are in place and interrelationships between the various sectors, systems, and components as part of the design process. If you recall, at the start of the course, we did cover the infrastructure sectors. So for example, we laid out transportation, water management, energy, solid waste management, public facilities, communication, and earth monitoring sectors. The topic of the assignment this week is to do a review of the St. Lawrence Seaway system, which obviously fits in the transportation sector, but it could have some other roles in other sectors. And that's something you'll have to think about when you do your assignment. In terms of the infrastructure sector relationships, we do have different sectors, as this diagram shows. In this case, we have the transportation sector, and it, for example, may have an overlap with the energy sector, or the structural sector, or the parks and recreation sector in this example. So sometimes one sector is connected to or related to another sector. System breakdown for transportation sector. So now we take the transportation sector and we break it down into the various systems or subcomponents. In this case, they've broken it down by the types of transportation system in terms of how we're moving things around. So we have a rail system, we have a highway system, we have ports and waterways, aviation, so we could have airports, things like that. And then we can take, for example, streets, the street system, and if we go to the next slide, we break that down into components or parts of the street systems, where we have lighting, traffic control, parking systems, collector versus arterial versus local street systems. So as you can see, we're breaking the main infrastructure sector down into systems, and the systems we can actually break down into components, and we can keep breaking things down, but what's important is that we understand all the different components or parts of an infrastructure system. And of course, we alluded to earlier, there has to be compatibility between the sectors, the systems, and the components, because we don't want to adversely affect another system component or subsystem. And sometimes we might go in and make a change or modification to some infrastructure. Again, we need to think about, okay, will this cause a downstream impact? For example, if we're changing something in stormwater management runoff, we're putting in a new subdivision, we don't deal with the stormwater management runoff, taking into account what's downstream, we could cause flooding downstream, for example. These are some case studies. The rest of these slides are case studies, so if you want to look at them and read them, they'll help you understand some of the different infrastructure system analogies. So have a look at this, and then you can work on your assignment, which I'm asking you to look at some videos and some content I'm uploaded on the St. Lawrence Seaway and answer some questions. Okay. I shall my commentary here. Perhaps I'll talk about this one, the interconnectedness of global shipping. This might be a good one to reread because it will relate to your assignment on the St. Lawrence Seaway. So assignment 7, which follows from this lecture and presentation, allows you to look at the St. Lawrence Seaway and answer some questions related to what we've talked here today. And this one has some similar systems and interconnections that the St. Lawrence Seaway, because it's talking about the Panama Canal. This is related to the connections of grids, and this is related to a flood project in Fort Worth, Texas. There is a video if you want to watch it. It just talks about that it is mainly a floodwater protection project, but how they involved other things and other infrastructure components to sort of make it fit better with the land use. And this is interesting. It talks about a standalone system where John Deere basically built its own city to support one of its major. This is an interesting account of a failure that occurred and how some forensic engineering found that it happened because of a change that was made somewhere in the system, which then led to a chain reaction that caused this failure.